In this episode, I want us to look at what is gravity. In classical physics, Isaac Newton demonstrated that gravity is a force between two bodies with masses, where the bigger objects attracted the smaller ones. Later in the early 20th century, Albert Einstein proposed another theory of gravity. He describes gravity as the deformation of space-time by mass and energy. In his general theory of relativity, Albert Einstein illustrated that massive objects create curvature in space-time, altering the paths of nearby objects and light. He called this phenomenon general relativity, and it explains phenomena such as gravitational lensing and orbit of Mercury. Albert Einstein observed that light was disobeying the equivalence principle and it could bend under influence of gravity. This theory was later proved by Arthur Eddington. He took photos of stars behind the sun during a total solar eclipse. The position of the stars appeared different than their predicted location as seen during the night. This was only possible if light from the stars behind the sun was bending following a geodesic path around the sun, which made them appear in a different location as they should be. To understand this better, I quote John Wheeler, who said, "Space-time tells matter how to move and matter tells space-time how to curve." From this, we can see gravity is not a force between two bodies with masses, but just a curvature in space-time due to massive objects in space. Now, from Albert Einstein General Theory of Relativity, we can clearly see how gravity works, but not what it is. Now, by combining Albert Einstein General Theory of Relativity and dark matter superluminal flow, I came up with the following hypothesis. Remember, space is not empty, but contains superluminal particles of dark matter, which travel faster than light, making it difficult for them to interact with light, and that's why dark matter particles are invisible. Again, remember, dark matter occupies space. Now, when visible matter forms in space, it occupies its own space, displacing the superluminal dark matter particles. This displacement makes the dark matter particles to be compressed around the object displacing them. When dark matter particles are compressed around the massive object forming in space, they increase their entropy. Entropy is just a measure of disorder. The more dark matter particles are displaced, the more the entropy. This entropy of superluminal dark matter particles is what we feel as gravity and pushes everything towards the ground or the surface of the object, displacing the dark matter particles, e.g. a planet or a star. This explains the equivalence principle, where we feel an upward force by the ground, yet the planet is not expanding. Again, remember, the bigger the object is in space, the more dark matter particles it displaces, therefore causing more entropy, and that's why the bigger the object is in space, the more gravitational pull it has. This entropy affects the formation of everything to the quantum level, giving rise to quantum gravity. Therefore, as we can see, gravity is just entropy of dark matter particles when displaced or compressed. Thank you, and continue supporting the channel by subscription and shares. And don't forget to leave any question and comment in the comment section.